Okay, this is Lewis Structures, Skills Practice 24 by Lucas Jackson. Alright, so there's three types of bonds. Single bonds are one orbital shared between two atoms. There's double bonds. It's two orbitals shared between two atoms. And triple bonds are three orbitals shared between two atoms. So here are some carbon-carbon bonds. Carbon can be bonded single, triple, or double, like a lot of atoms. Alright, the length of these bonds decreases as it goes from single to triple bonds. It goes from 150 all the way to 120. They're getting closer together. The bond energy also, that increases because it's a stronger bond. It's harder to break. The bond energy is higher. So the order of a single bond is 1, the order of a double bond is 2, and the order of a triple bond is 3. Order is just a value meaning type. So this is benzene. It's got a carbon chain in it, and the carbons are single and double bonded. And so there's 3 order 1 bonds and 3 order 2 bonds, but they're really all actually the same order. They're the same length, they're the same distance apart, and they have the same bond energy. None of them are easier to break from each other. So the actual order is the average order of all the bonds in between the carbons and benzene. So that's 1 plus 2 plus 1 plus 2 plus 1 plus 2 divided by 6. It gets you 1.5. This is resonance structures are different forms of a molecule. Benzene would have 2 different forms. There's one different version where the double bonds could be. The actual molecule is between the resonance structures. It's like in an average place between the 2 structures, or the 3 structures or more, like in nitrate and sulfate. There's different places where these bonds can be. So here's question number 1. Draw all the resonance structures for CO3 minus 2. So carbon has 4 valence electrons. Oxygen, there's 3 of them with 6, 18, plus 2 more electrons to give it the -2 charge. There's 24 total, and you have 1 oxygen that's double bonded to 2. They're single bonded, they're each negative. That is the carbonate ion. So now we do the resonance structures. These are the 3 resonance structures. There's 3 different places where the double bond can be in the molecule. Alright, and with the bond order for the CO bonds in CO3 minus 2. So you need to take the average of the order. So there's 1 single bond and 1 single bond. There's 2 single bonds and then 1 double bond. And divided by 3, that gets you about 1 1/3 is the order of the bonds in CO3 minus 2. Alright, which CO bonds are longer? The ones in carbon dioxide or the ones in carbonate? The ones that are longer are the ones in the carbonate ion, because the ones in CO2 are pure double bonds. They're not in between single and double bonds. They're as strong as double bonds. So the ones in carbonate are actually weaker, so their bonds are longer. Which ones are harder to break? The ones in the carbonate ion or those in carbon dioxide? So carbon dioxide is actually harder to break because those are double bonds, and carbonate, they're kind of between single and double bonds in terms of strength. Double bonds are harder to break than single bonds. Alright, so in general, the stronger the bonds, the longer shorter the bonds. In general, double bonds are longer, shorter than triple bonds. Bonds with a low energy are stronger or weaker than bonds with a high energy. In general, the stronger the bonds, the shorter the bonds. The closer the 2 atoms are together, the stronger they're bonded. In general, double bonds are longer than triple bonds because they're weaker, so they're a little bit more spaced apart. And bonds with a low bond energy are weaker than bonds with a high bond energy. They require as much energy to break them apart, so they're weaker bonds.